Hi all, welcome to my tutorial on generating XY scatter plots and performing least squares linear regressions in both RStudio and Excel. So both RStudio and Excel are statistical programming interfaces which allow us to analyze data and represent our analyses graphically via plots. Now, both RStudio and Excel have advantages and they both have disadvantages. Sometimes it's better to perform a process in Excel and sometimes it's better to go with RStudio. It really just depends on your needs and what you're trying to do. Additionally, sometimes it's best to use them in conjunction. And actually, that's fairly common as well. So let's go ahead and get right into this. I want to use a instructional chemistry lab type example to illustrate these analyses. So let's take a look at Charles' law. So Charles' law is derived from the ideal gas law, and it's often represented as we see here. The volume of a gas divided by the temperature of the gas is constant as long as pressure is held constant. So if you have a gas with V1 and T1, where those are specific values, and either one of those is changed, then the other measurable parameter is going to have to change in a way such that the volume to temperature ratio remains constant. So let's go ahead and get directly into this. So here I have an Excel spreadsheet that's been saved as a CSV file, and it's titled Charles Law. So charleslaw.csv, and it's saved in a folder in the desktop. Now, it's a pretty simple spreadsheet. I only have two columns. I have the temperature of a gas, which in this case happens to be air, and the corresponding volume measurements that go with those temperatures. So in this experiment, at 100.3 degrees Celsius, the volume of air was measured after correction for humidity, was measured to be 140.2 milliliters. Upon decrease in temperature down to 23.1 degrees Celsius, the volume of the gas also decreased and was measured at 108.3 milliliters. At 10.1 degrees Celsius, the volume of air was measured to be 105.4 milliliters. So we have these two columns. So we really have three data points, right? And each data point has a temperature component and a volume component. I want to go ahead and generate the XY scatter plot in RStudio. So let's go ahead and open that up. So upon opening RStudio, this is the type of interface that you should see. This is where you're going to be executing code in the console. When we generate plots, we'll see them down here. And when we import data into R, we're going to see it here listed in the global environment. So the very first thing that we need to do is we need to set a working directory. So that can be accomplished by going to Session, Set Working Directory, Choose Directory. So recall that we're trying to look at this data. So again, charleslaw.csv, and it's saved in a folder on the desktop with the name StemVids. Here it is. So we've set the working directory now. So what I want to do now is I want to import the data in this spreadsheet into RStudio. So again, this spreadsheet is in the working directory. So we have to set that first. So I'm going to call this spreadsheet Charles Law. And remember that it's saved as a .csv file, so we need to use the read.csv code. And remember that that file, that Excel spreadsheet, is titled charleslaw.csv. So we can now see that it's been brought into our global environment. So I want to do an XY scatter plot, right? So I can do that by assigning X values from one column and Y values from the other column, paying attention to what I want on which axis. I want temperature on the X-axis, and so to assign temperature to the X-axis, I'm going to call the temperature column. And because I want the corresponding volumes on the Y-axis, I'm going to call the corresponding volume column. Because I want to do a least squares linear regression, a LINEST, on this data, I need to establish a linear model for analysis. And I'm going to call this, I'm giving it a name now, linear model Charles Law. And the way we can establish this linear model is with the code LM, linear model, where Y is proportional to X. Okay, so we've now established our values for the X-axis, corresponding values for the Y-axis, and our linear model. Let's go ahead and plot our data points now. So we can do that with a plot command. So let's just see what happens if we plot X and Y. Pretty basic plot, but nonetheless, it looks good. We have 3 data points which correspond to the values in each column. Let's go ahead and get a little bit more sophisticated though. Let's go ahead and label the X-axis using xlab. And so I want to go ahead and label that temp of air, and it's going to be in Celsius. Let's go ahead and label the Y-axis ylab, and that's going to be volume of air, and that's going to be in milliliters. Oops, milliliters. Let's see where that gets us. All right, that looks good. So we can see now that the Y and the X-axis have appropriate labels. So one thing that's good about R is that if you like the code that you just executed, but you'd like to add something to it or modify it a little bit, you can grab it again by just pushing the up arrow on your keyboard, and then you can modify that code. So I'm going to go ahead and put a main title on, and that's going to be Charles Law for, and because this is going to be kind of a long title, we're going to go ahead and go to a new line. So we can do that with /n, Charles Law for determination of absolute zero. Let's see how that looks. Okay, that looks good to me. Notice that the axes are cut off between 0 and 100 and about 105 and 140 for the y-axis. I want to go ahead and expand these axes. I want to stretch these axes, and so we can do that with the code xlim. So this is going to be for the x-axis, and we're going to do a range. And let's go on the x-axis, let's go from -300 up to 100, and I chose -300 because we know that the accepted value of absolute zero is -273. So provided that the data that we have here is accurate, we should get pretty close to negative 273. So I wanted to go just a little bit beyond that. Let's go ahead and stretch the y-axis with y-lim, and we're going to go range, and let's go negative 10 up to, let's keep it up at 140. Let's see how that looks. Okay, that looks pretty good. So I like this plot, but I want to plot the best fit line for these three data points in this plot. So we can do that with AB line, and we're going to do that to the linear model which we established earlier right here. This is the linear model where y is proportional to x, and we titled it linear model Charles law. So I can actually just clip here, AB line linear model Charles law, and there we go. Now we don't have the equation of the line, right? But that can be had using a summary code, and we're going to do a summary of the linear model. Boom. And this is how R gives us the equation of the line. So it's actually giving us a y-intercept right here. I'm going to round it to 4 sig figs, so a y-intercept of 100.4, and that's actually with units of milliliters, right? 104, and we're getting a slope of 0.3953, and notice that RStudio gives us two r squared values, the multiple r squared and the adjusted r squared. We're going to go with this one because this is the same one that Excel gives us, 0.9966 for r squared. Okay, not bad. Very linear, sufficiently linear, and it looks like it's coming down somewhat near negative 273. So let's go ahead and add the equation of the line to our plot. So we can do that using an mtext code. So we're going to go ahead and do mtext, and I'm going to write the equation of the line in terms of our y and x-axis labels. So I'm going to go volume of air in milliliters is equal to 0.3953 times temp of air, and that was in Celsius, times temp of air, and let's go plus the y-intercept 100.4, and that technically has units of milliliters, so let's just include those. And for positioning of this equation of the line, actually, you know what, let's add the r squared in there as well. So let's do the r squared in a line below the equation of the line. So what we're going to do again is we're going to go /n, and then we can go r squared is equal to 0.9966. And then for positioning, we can go ahead and use a side and at code. So we're going to go side 3, and we're going to go at, let's go negative 150, negative 4. So I'm not quite liking the position of that. Let's do this instead of actually, let's see what happens if we try to change the positioning a little bit. So let's see. Let's go instead, let's go -3 and see where that takes us. It's a little bit better. See what happens if we go -2. Okay, that's pretty good. So let's see what happens if we change the 150. Let's go ahead and change that to 125. Okay, that's going to work for us. That's going to work for us. So what I'm going to do now is I'm going to regenerate this whole plot right here. And so this plot, like the basic components of this plot minus the trend line and the equation on the line, were given by this code right here. So I'm going to go ahead and copy that. I'm going to go ahead and re-execute that. And remember that we got the equation on the line from this code right here. So that gives us the equation on the line. And we don't need to re-execute summary here because actually we have that information here, and that information hasn't changed because that corresponds to our data points, which haven't changed. We're just kind of refreshing the plot right now. But what I do want to do is I want to put the equation of the line in a better position. So remember that this is the code. We executed the mtext code a few different times just to kind of move the equation of the line around a little bit to a more appropriate position. So again, this was the mtext that gave us the equation that we wanted. So I'm going to go ahead and re-execute that, and that's going to work for us. That's going to give us the equation of the line in a way that that works out. So what we can do now that we have our plot, is we can go ahead and save it as a PDF. Let's go ahead and preview that to make sure that it looks good. That looks good. We could move this down a little bit, but let's go ahead and just leave it as is. Let's go ahead and save this. Let's save it in the same folder as the folder containing the Excel file that we started with. So that was STEMVids, and we'll call this the Charles Law PDF. Save. Alright, so now we have this plot. So we've sufficiently performed a least squares linear regression in RStudio with our experimental data. We can do the exact same thing in Excel, and let me show you how I would do that now. So we have these two columns. I would highlight, go to Insert, go to Scatter Plot. We only want the data points. We don't want lines connecting the points. So we're going to go just here with the scatter, and we can go ahead and add a title here, and we're going to call this Charles Law for determination of absolute zero. Okay, that looks good. Now let's go ahead and add axis titles. So again, let's call the y-axis volume of air in milliliters, and the x-axis will be temp of air, and that's going to be in Celsius. Okay, that looks good. Let's go ahead and add a border here. Let's go ahead and do a border. Let's do a solid line, and let's go black on that. Let's see how that worked out. Okay, so that gave us the border here, but we got to do the axes separately. So let's go ahead and do a solid line on the y-axis, and yeah, we're going black, and then let's do the same thing on the x-axis. That looks pretty good. Let's go ahead and do an outline around the outside as well. So let's do solid line, and yep, it's going to be black. Let's see how that worked out. That looks good. All right, let's go ahead and change these axis bounds, just like we did in RStudio. So for the x-axis, I want to go from negative 300. And let's just leave it up at 120. So let's see where that gets us. So that actually moves our label into the inside of the graphing grid. I want to go ahead and get that out of there. So I'm going to go ahead and move the labels for the y-axis to the left side. So now it's outside of our graphical area. So I like that. Okay, this is looking pretty good. All right, let's go ahead and do the linear regression. So we're going to go ahead and add a trend line. It's going to be linear. Let's go ahead and display equation on the chart, display r squared on the chart. And I want to extend this line forward and backwards. So unfortunately, sometimes when you do that in Excel, it also changes the axis. So it can take a little bit of adjusting, but we can do it. I also want to make this trend line, I want to make it black, and we're going to go ahead and make it a solid line, a little bit less thick. Okay, that's looking pretty good. Let's go ahead and get the equation line in the r squared moved out of the way a little bit. And let's go ahead and forecast the line forward. Let's try. Let's see what happens if we go with 50. Let's see what that gives us. Let's go ahead and go with 40 and see what that gets us. And then let's go backwards. See what happens if we go negative 260. Actually, we can't use negatives. Let's go backwards 260. So backwards looks pretty good, right? But we're going to need to adjust this axis now, actually. The y-axis. So I want to make the maximum now. Let's make the maximum 155. Let's see how that looks. And let's make the minimum again 0. And then let's go ahead and take this equation and let's go ahead and adjust it like we did in RStudio. So we have volume of, and again that gas is air, in milliliters is equal to 0.3953, and that's going to be times temp of air, and that's in Celsius, plus 100, and let's go ahead and round that to 1 decimal place, 100.4 milliliters. And let's go ahead and move that a little bit again. The equation gets a little long when you adjust it as we have. Okay, that looks pretty good. So if we wanted to just print this, we could just go ahead and copy this and then go into Word, blank document, post it into there, and then we could, arrange exactly where we want it and such. All right, so that's pretty much it for generating XY scatter plots in both RStudio and Excel, and performing corresponding least squares linear regressions, obtaining the equation of the line, r squared values. So, either way works. I like Excel. I like RStudio. Sometimes it's better to use one over the other, but you might want to just familiarize yourself with this tutorial and the coding involved in RStudio so that you're able to do more in RStudio. All right, and that's pretty much it. So thanks for watching. Hope it was informative. All right, have a great day.